maths for me and you. Let's learn maths together. Hello everyone, here we answer question number 2. This question we answer based on the theorem of Pythagoras. Question is, PQR is a triangle right angled at P and M is a point on QR such that PM perpendicular QR. Show that PM square equals QM times MR. So let's draw a right angle at P, and you can see PM perpendicular to QR. Let's start. QPR is the right angle at P, and PM perpendicular to QR. Then we can see big triangle QPR and two other smaller triangles. Consider the big triangle QPR. Here P is the 90-degree angle and QR is the hypotenuse. According to theorem of Pythagoras, we can write QR square, hypotenuse square, is equal to sum of the sides square, other two sides square, QP square plus PR square. Let it be equation number 1. Then we consider one of the smaller triangles. Here I marked as 1, and you can see that is also a right angle triangle. QP is the hypotenuse. Here also we can apply the theorem of Pythagoras. Then we get QP square is equal to PM square plus QM square. What we need to show is PM square. So keep PM square in one side and we can find what is PM square. PM square is equal to hypotenuse square QP square minus QM square. Let it be equation number 2. Now moving on to the next smaller triangle. Here I marked as 2. That also a right triangle, and PR is the hypotenuse because it is opposite to 90 degree. Again we use theorem of Pythagoras. PR square is equal to the sides PM and MR. So we can write PM square plus MR square or RM square. Again we will start with the PM square because we need to find PM square. So we can write PM square is equal to PR square is the hypotenuse minus RM square. PR square minus RM square. Now this is equation number 3. Equation number 2 and equation number 3 we get PM square. We can do equation number 2 plus equation number 3. Equation number 2 plus equation number 3. Then what we get? Left side PM square and PM square. We get 2 PM square is equal to, on to the right side we have positive terms QP square and PR square. Connect the positive terms QP square plus PR square. There we can see negative terms also, minus QM square minus RM square. We write them minus QM square minus RM square. Then we can see QP square plus PR square. We can replace using equation number 1 as QR square. So QP square plus PR square, we get QR square. Then the negative terms same, QM square minus RM square. What is QR? When we look, QR is a line with M is a point on that side. So we can say QM plus MR will give QR. QR we can replace as QM plus MR or RM the whole square minus negative term same, QM square minus RM square. QM plus RM the whole square. Let's open using the identity A plus B the whole square. What is A plus B the whole square? A square plus 2AB plus B square. Same way we can open that bracket. QM plus RM the whole square, we can write QM square plus 2 times QM times RM plus RM square. So we get the expansion of that minus QM square minus RM square. Same we write. Now we can see QM square minus QM square cancel. Also RM square minus RM square, they also get cancelled. Finally, we have on the left side 2PM square. And on to the right side, we have 2QM times RM. On both sides 2, so we delete or cancel 2. Finally, we get PM square is equal to QM times RM. That's the proof.